In this video, we're going to prepare our project for Chapter 10 and prepare the environment for at least the load data exercise. So we'll describe the load data command and how that's used just briefly, and to demonstrate how it's working and what it's doing. Let's go back to what we did in a previous chapter where we practiced dumping the database. And so we're going to drop all of our tables and start fresh, basically. So I just refreshed this to show you that there are 20 tables in my database right now. I'll right click and open my query tool. And I'm going to want to execute this drop and create schema command, which will delete all the tables and basically recreate the schema. So then if I refresh this, we can see that I in fact have no tables. So going back to our code, we do want to make sure that we are importing our chapter 10 URLs and commenting out our previous chapter 9 URLs. In our settings.py file, also make sure that we have installed and created the chapter 10 app within your project. Within your chapter 10 urls.py file, go ahead and make sure that we have these three paths created, and also activate a admin panel and a home page for this app. And because we did just drop all of our tables in our database, what we are going to want to do here is run our migrate command. And the reason why I didn't run the make migrations command is because I already have migrations for all the models that exist within this project already created. There's no conflicts with the migration files in any way, so if I do start fresh, all I have to do is run the migrate command. So now let's just head back over to pgadmin real quick and see that now we do have the 20 tables back in our database. And let's just go on a couple of these tables and just look at see what data exists. So I'm going to select this chapter 3 vehicle table. I'm going to see that there's nothing in it at this time. I'm going to do the same for the chapter 3 sellers table, and also see that there's nothing in it at this time. So now to load the chapter 3 fixture, which is located in the chapter 3 fixtures app called chapter_3.json. Django will automatically assume there's a .json file extension, so that is not needed for you to actually write that. We don't have to specify a folder because Django is automatically looking for a fixtures folder inside of any application that exists within your project. So one of the things is that you do have to have your application added to your installed apps variable within your settings.py file in order for that to actually work. So then if we run this Python manage.py load data chapter _3, we're going to load all of the content within this file, which include vehicle models, engines, several vehicles, and a seller. And so the vehicles and the seller are the two tables that we're going to monitor, and just watch to see if data is actually being added to the database. So we see that Django tells us 13 objects from one fixture was installed. And what that means is, since we're specifying chapter 3 here, we could specify an entire app if we wanted to. So heading back to our database management tool, I'm going to just refresh or re-execute the seller select all from the seller table command. And this time it actually gives us information. We know that there was only one seller that was included in that fixture. I'm going to switch over to the vehicle tab that I have opened. And I'm going to re-execute that select all from the chapter 3 vehicle table. And there were 7 objects that were included in that fixture that now exist within our database. And so now we are prepared to work on the next videos, where we will be dumping data and creating fixtures automatically. And this also concludes how to load data into our project. In this video, we will practice using the dumpdata command for the first time. And what this will do for us is we're looking at our chapter 3 .json data fixture right here. And a dumpdata command will essentially produce outputted data in the same format and structure that you see here, with some variations based on the parameters that you include on one of these commands. And so just using it in its basic form, what we're going to do is dump everything that exists within our database right now into a fixture. And prior to doing this, when preparation for chapter 10, I did load the the chapter 3 data fixture into the database. So all of that data does exist at this time. And so going to our command line and making sure that your virtual environment is activated, we can go ahead and execute this Python manage.py dump data, and it's using the -o parameter or attribute, which specifies the location of the output where we're going to put this file. So if you don't specify that, it's going to output it in the same folder as your manage.py file. But here we're going to nest it 3 folders deep and call the name of that file chapter _10. And if we look right here, we don't have any of the files, or any files within our chapter 10 fixtures folder. Do make sure that you create this fixtures folder within your chapter 10 app before executing this command, or else it's going to error out because the folder doesn't exist. And so here it just prints a bunch of dots indicating that those objects were created. Each dot represents an object that was created within that fixture. So we also see here that I now have a file within the fixtures folder, and that is the chapter10.json file that we created. And so if I open this up, it's going to show you a very minified version of the data that was produced. If you're using the Visual Studio IDE, you can just right click and select Format Document, and here you can now view the data in a way that's actually readable. So we see that it includes every piece of data that exists within our database, including the auth application, where we've got our permissions, our groups. This is where the user object would be stored in a traditional Django project. Since we do have the auth user model set to use our chapter 3 seller model, that is why the user doesn't exist in the auth app. And so then here we get into the chapter 3 data, and all of this data is going to appear exactly as it does in the chapter 3 fixture. I was in the wrong file for a moment. So in the chapter 10 fixture, we have all the content types, which are Django related models. And then we get into the chapter 3 fixtures, and these appear exactly as they do in our chapter 3 JSON file. So here, if we compare the first one in the list, this Envision vehicle model, we see that it's the same exact data. Unless you edited any of your data while you were in the admin panel, then you may see a difference in values. And here we see the chapter 3 seller model, which essentially is an extension of the user model. And so that's why the passwords are actually stored in their hashed format, so that you can't actually read what the password is. And that is how we use the dumpdata command. In this video, we're going to export a specific application and also a specific table. And so the first one we're going to do is export all of the chapter 3 models that exist. So we'll exclude any of these auth app models and the content types. Anything that's not a chapter 3 app will be excluded. And well, technically it's not going to be excluded. We're just not going to target that. So to run that command, the first example we're going to do is run this manage.py dump data chapter 3, and that's where you specify the name of the app that you want to export. And then the output is exactly the same as the previous example, except this time we're going to name this one chapter 3 models. So now we can go and look at the chapter 3 models fixture that was just created. And again, right click to format your document and make it readable. And we could see that everything that's included in this list is actually the chapter 3 app and nothing else. And then if we wanted to export a specific table, and in this example we will export only the sellers table. So in this new fixture we should expect only this object. And so here we run python manage.py dump data, and then the name of your app, and then in Python dot notation the name of the model that you wish to export. So here it's chapter underscore 3 dot seller, and that's all in lowercase to match how everything does get renamed in lowercase when the data structure is actually created in PG in PostgreSQL. And so here we are expecting only the one object as it does appear here. And so that is how you export a specific application or a specific table. In this video, we're going to practice dumping data using the exclude option. And so the point of this exercise is to not target a specific app or a table, but to target everything and exclude only what we don't want. So in other words, trimming the fat. And what we want to produce is the same output as the chapter 3 models, where we only consist of all of the chapter 3 tables. And so how we'll do that is by running the python manage.py dump data, and you could either use a single dash and the letter E, or you could use 2 dashes and spell out the word exclude. They both work the same, and what I mean by that is instead of dash E, like you see here, dash exclude will also work. So this is a much easier way of writing it, in my opinion. So here, for each app that we wish to omit from this fixture, you have to include another dash E. So we have dash E content types, dash E sessions, dash E auth token, dash E auth, and dash E admin. And if not all of those apps have any models, but if they did, they would definitely be excluded. And then we use the dash O option to again specify the name of the file that we want to dump this information into and the location of that file. And here it's going to be called chapter 10 underscore exclude. And so we'll just go ahead and run this. So here we have the chapter 10 exclude file, and if we format this so that we could read it, we'll see that only the chapter 3 tables exist within this file. And if you've been working, if you're working out of sequence in this book, and say you didn't include the REST framework models and you tried to run this example from this chapter, you might run into this error right here, which is nothing to be concerned about. Just make sure you include these apps, or get rid of this option right here within your command, and then you can run it. And that is how to use the exclude option when dumping data. In this video, we're going to practice dumping data using the format option. And what we want to produce is the equivalent of when we produce the chapter 3 sellers.json file that consists of only the seller table data And since we only have one seller within our database at this time, this is why there is only one object within within this fixture. And so by default, Django automatically dumps everything in JSON format. If we wanted to dump it in any of the other three formats, we would have to use the -- format option. And so that would look a lot like this example here, where I'm using the Python manage.py dump data, and here it's the name of the app and the table, or you can omit the name of the table if you just wanted the app, and you can omit the app if you just wanted to include everything. And then -- format, and then specify the format type, which is either XML, JSON, JSON-L, or YAML, which is YAML, are the four different format types that you can that Django supports. So this example is in XML, and then the output is the same. And here I am specifying the same name as our JSON exercise where we exported the Chapter 3 sellers fixture. This one I'm going to give it a .xml file extension because it's an XML file. And so running that command, we can see that this is what the JSON structure looks like. So when we open the XML file, we'll see that it is a completely different format. Visual Studio doesn't support a auto format for. There's probably a plugin for that. The next example, let's go ahead and export as JSON-L. So again, the same thing, except we're going to change the format to JSON-L. The name of the file will remain the same, but the file extension gets changed to .jsonl. And we can see that the file was produced, and this one we can actually format, and it looks fairly similar to a JSON format, but the L stands for light, I think. I wouldn't quote me on that one actually. And then the last example will be in YAML format. So again, the same command, except we're changing the format to YAML, YAML, and the name of the file remains the same, but the file extension gets changed to YAML. And so opening that up, it is already formatted for us, and this is what YAML format looks like. And that is all of the formats that are supported by Django. In this video, we're going to practice dumping data using the natural primary option. And what this does is, if we're looking at our chapter 3 sellers.json file that we created in a previous video, the single object that it created did produce this field called PK, which stands for primary key, and it gave it a numeric value of 1 because it's the first object that was created, it's the first object that exists. Sometimes when you're importing and exporting data, having this primary key can be problematic. And so if you wanted to quickly generate a fixture that did not include the primary key, you would use the natural primary option. And so in this example, we're going to produce this exact same fixture without the primary key. By executing the Python manage.py dump data, here we again specify the chapter 3 app and the seller table. And the option is -- natural - primary. And then we again use the output option and specify the name of the file as chapter 3 sellers natural primary.json. And so if we open that file and format it so that we could read it, we will see that the primary key field does not exist. And these keys, however, do exist. These are actually foreign keys that relate to a different table. And so that is how you extract data using the natural primary option. In this video, we're going to practice dumping data using the natural foreign option. So in the previous exercise where we used the natural primary option, we exported data that does not include a primary key. Now, if we did that, it could also become very problematic if we have many-to-many or even foreign related objects that consist of foreign keys that point to what should be primary keys that don't exist. So it's not guaranteed to fail every time because these may line up with how those objects get created into your database. However, if that was a problem and you do have a string representation that is unique enough to differentiate between two different objects, then you could use the natural foreign option. And so what I mean by that is, let's go ahead and execute this command, the Python manage.py dump data, and we name the app and the table that we wish to dump, which is the chapter 3 seller table, and it's -- natural - foreign for the natural foreign option. And then we specify the output as chapter 3 as sellers natural foreign.json. So if we go ahead and open up the file that was created and format it so that it's readable, we'll see under the vehicles list, we no longer have a set of numeric values which represent the primary keys of each of these objects as a foreign key. Instead, they now have actual titles or names written on them. And what I meant by as long as they're unique enough, we could see that even some of them within my list appear to be duplicated, or even this one appears 3 different times. So if we ever did a lookup and we needed to match these exactly, these 3 right here would wind up causing some problems and some pulling of some hair. But that is what you would do, or that is how you would use the natural foreign option, at least. In this video, we're going to practice using the select related method, and this is a method that is used to help optimize and speed up how data is actually being queried within your system. So it's used in conjunction with anything that is a .all a .filter, a .get, or even Q queries or the F queries. So to start this example, what we'll do is we do want to make sure your Chapter 10 app is installed and running. In our Chapter 10 views.py file, create a class called vehicle view, which will use the view class that we import from the Django views.generic library. We will also need the HTTP 404 class from the Django HTTP library. We'll also need this template response class that comes from the Django template.response library. And also make sure you import the vehicle model that we'll actually be working with. Here we specify the template name as our Chapter 10 vehicles.html file that we're going to create in a moment. And just write a single get definition. And here we're just simply going to try to query all the vehicle objects as this vehicles variable. The except statement is except vehicle does not exist, and then we want to raise a 404 no vehicles found if that is the case. And then we need to return the template response, and that is the where we specified the template name. We pass in the request and a list of context variables, and here we're going to set the vehicles as the vehicles variable we created here. So now we want to build the template, and so if it doesn't exist at this time, create this Chapter 10 vehicles.html file found here within your Chapter 10 templates Chapter 10 folder, and go ahead and include all of the HTML that you see here. And for this first exercise, leave out this for loop. We're not going to need this for the results that we have here. You could either use the comment tags. I notice if you use these as a comment that Django will still execute this query. But I do use both because this actually formats it in the color green within my editor, whereas if I didn't, it would appear as that. And these are appearing white because I just created it, and there's a weird bug where once I close my editor, it'll turn blue when I open it again. But aside from that, we do want to create a new URL pattern in our Chapter 10 URLs called all vehicles. And here we'll point to the vehicles view that we created and imported here. And again, that also relies on you importing the Chapter 10 URLs in your main urls.py file. So now if we make sure our project is running, we can go ahead and navigate to the all vehicles page. And if I go ahead and I refresh this page, we'll see that I actually have 15 queries. And if we open that up and look at what those queries are, here we can see that it is looking for a vehicle, Then it looks for the related vehicle model, related engine, related vehicle model again for that engine relation, and so on and so on for each of the vehicles that exist. So what the select related function would do is it would select all of the related vehicle models and related engines pertaining to a particular vehicle. And we'll just go ahead and look at the vehicle class in chapter 3 models.py real quick, and we'll see that 2 of the fields are foreign key fields, and it's the vehicle model and the engine. So what we're optimizing here is how it looks up a vehicle object. So if I save that and I refresh this page one more time, we'll see that this time we only have one query. So it, in one single operation, looked up all 7 of the vehicles and all of their related objects. And that is how you use the select related method within the first demonstration. In this next video, we're going to practice using the prefetch related method on the vehicle's view. So picking up where we left off when we used the select related method. What that operation did was looked up all of the related objects pertaining to a vehicle. So if that vehicle has a many-to-many or a foreign key or a one-to-one relationship, those particular fields are what the select related method is best used for. So in this exercise, go ahead and make sure that this this select related query is present, and the prefetch related will allow us to look up any of the related parent objects. So going back to the models, chapter 3 models.py file, when we look at the vehicle class, we see that it only has 2 related objects, and that's these 2 fields here. But if we look at the seller table, we'll see that it has a many-to-many relationship pertaining to the vehicle class. So the seller would be the parent of the vehicle in this relationship. And so the prefetch related will relate any of the sellers pertaining to that vehicle. So where you're specifying vehicle sellers, we're relating to the related name of the many-to-many field found on the seller table called vehicle sellers. So I'm going to comment that out and use this one instead, but if I highlight it, you'll see it's the same field, the same example. So to start the second demonstration, we want to make sure that this is turned on first, because we want to see what happens before we apply the prefetch related performance booster or performance optimization, however you want to word that. Within the chapter 10 vehicles.html file that we created, and make sure you save your file too. It's a bad habit of mine. This is where we want to uncomment the seller loop that we have here. And we want to see what happens when this loop is included in your file. And so now we can go ahead and we can run this. And we'll see that in this particular example we do have 8 queries. And we have the initial vehicle, that same query that we found from before. But the additional 7 is because each of the 7 vehicles that exist in our database each have a single related seller. And so it's hitting that seller 7 different times. So now, if we go back to our code in the vehicles view class, we'll comment out this query lookup with the select related, and here we'll use the prefetch related, but we're still using the select related. We're just tacking this on before. And now when we go to this page and just refresh the page, we'll see that we have 2 queries. The first query is for all 7 of the vehicles that exist within our database, and the second query is for each of the sellers that relate to each of those 7 vehicles. And that is how you use the prefetch related method within the second demonstration. In this video, we're going to continue to use the prefetch related method. This time we're going to use it on a seller's view instead of a vehicles view. Whereas before, what we were doing was listing all of our vehicles with the list of just the seller names that displays under the details of the vehicle itself. Again, nothing fancy. This is just data from the back end. No front end was really applied here. So for this one, going back to our views.py file, we'll still need the HTTP 404 class, the template response class, the view class, and this time we'll actually need the seller class from our chapter 3 models. And so this is where we're going to write a seller's view. And we're going to define the template name as chapter 10 sellers.html. And we're going to specify a single get definition where we're going to try to look up all of the seller objects as this seller's variable with an except statement that says sellers or seller does not exist, and then we will raise the 404 page with a message of no sellers found. And then we will return another template response passing in request, the template name, and a list of context variables where we're passing in the sellers if they're found. Next, we'll build the template, which is our chapter 10 sellers.html file in the chapter 10 templates chapter 10 folder. Here you'll load the static tags and chapter 4 template tags. So this is another reason we need to have all of the previous apps turned on. so that way we can access this chapter 4 templates tag file because we are referencing this vehicle make filter. So if you're not importing that, make sure you're getting rid of that filter within your code. I've included some CSS. This is not necessary, but you can go ahead and copy this if you wanted to. And then I formatted just a single H1 tag. And then we're going to check to see if sellers exist, because if it's not found, well, actually, if it's not found, it's just going to raise 404. Otherwise, we would have to specify maybe sellers equals none up here. But that's not necessary since it won't actually be required here. And then, so if sellers are found, we do want to create a loop that loops for each seller in the sellers list, and then print out just some basic details about that seller here. And we'll leave that at that for this particular moment. And for this one, we are going to use this example right here. If seller.vehicles.all. So if it's a many-to-many relationship, you do need to use the .all. Otherwise, if you use just seller.vehicles, it's not going to be able to iterate through that list. And then we're going to print all of the seller vehicles. I'm using an H2 tag here so that I can differentiate between the two different for loops. And for vehicle in seller.vehicles.all is where we're going to print out the information pertaining to that particular vehicle. And so for this one, we are going to map a new URL pattern called all sellers, where we're linking to the seller's view that we created in that views.py file. And so now we can go ahead and navigate to the all sellers page in our browser and make sure that your project is running. And so we can see here, I have 17 queries in this particular example. I have the list of sellers. We know that there's only one seller in my database at this time, so this is only going to appear once. Otherwise, below this line, I would see that information being not duplicated, but I would see another set of that for the next seller in my database. But here I see the second loop that was created for the seller vehicles. So this is where all 7 of the vehicles pertaining to this first seller are now displayed. And I can get a breakdown of the information for that vehicle. So now if we go back to our view, and I again comment out the first query and replace it with this prefetch related, where I'm going to prefetch the vehicles, and for each vehicle I'm going to prefetch its related vehicle model and related vehicle engine. And then I will refresh this page and see that this time I actually have 4 queries. I'm not exactly sure why I got 17 when I first ran through and wrote this. I originally got 19. So sometimes Django does that, but the reality of the matter is that I probably did something out of order in executing my code versus the order in which I wrote the code for the book. So sometimes when you're writing code as well, you might commit something and then go work on a feature branch here, and now you're backwards and forwards in history in terms of how stuff actually works. So you might see some variances from time to time. Just remember that it's a very fluid environment, so things are always changing, especially as you change your code. In this video, we're going to practice using the prefetch class. Now this is pretty similar to how the prefetch related method is used, except it allows us to write our own functionality and our own constraints. So how we're actually going to use it in this instance is to filter and show only the vehicles that are of a particular vehicle model. Looking back at the results of our last example in the third demonstration, what we have here is a list of all of the vehicles pertaining to this seller. So we have a slew of different models. We've got Blazer LT, Blazer LT, Blazer LT. Then we've got an Envision, then we've got an Enclave, then we've got another Blazer LT. So of the 7 objects here, 5 of them are a Blazer LT. And what we will do is look up the Blazer LT. And so in our chapter 10 views.py file, and the same seller's view that we worked with in the previous video, we do want to actually add this import statement from the django.db.models library. We're going to import the uppercase prefetch class. And then we will we'll comment out the previous query that we used in the last example, and instead we're going to use this query where we're still writing it as seller.objects.prefetchRelated, except within this method, instead of defining our fields like we are here, which seems pretty simple and easy, it now gets pretty confusing, where the first parameter is your prefetch class, and then that class accepts different parameters itself. And additionally, what I'm doing after the fact is I'm performing more prefetch related operations based on the results of this first prefetch class, this filtered vehicles object right here. and then we have the .all after it. So the prefetch class is responsible for using this query set attribute or option to then perform the vehicle.objects.filter operation, and we're only going to look up a vehicle model name field that equals a Blazer LT. We're prefetching related vehicles. Which is the lowercase vehicles table. And then the to attribute is what we're outputting it as, and so this is where we're using it to filter here as additional prefetches. And then in our sellers.html file, what we are going to do is we're going to comment this one back out and use the if seller filtered vehicles condition here, where we're going to loop through all of the seller filtered vehicles. And in this particular one, we do not need to use the .all at the end because this is already formatted in a way that Django can iterate. And so here we're going to print the same details for the vehicle again, written in the exact same way. So now if we go back to the all sellers page, making sure that your project is running, we'll go ahead and refresh this page and see that I still have 4 queries. That didn't change any. I think this number went down a little bit. I could be mistaken, but I'm pretty sure it went down. And then scrolling up to the top of the page, we see that this information is still the same. And then under our seller vehicles, we'll count 1, 2, 3, 4, 5 objects instead of 7. And we know there's 7 objects in our database. But we see that each one is now a Blazer LT. So we know that the prefetch class that we wrote here is actually filtering the way that we want it to filter. And so that concludes how to use the prefetch class in the 4th demonstration.